Hello friends, today I am going to start with the next topic related to high voltage engineering, that is corona discharge. The theory related to the breakdown and post breakdown phenomenon is already studied in previous topics. In this, we are going to study the post breakdown phenomenon, that is arc, but it is referred as a corona discharge. This corona discharge basically formed in between the gap of the electrodes, or maybe on the surrounding, that is transmission lines, etc. Here we are going to study two types of the gap and the corona discharge which takes place in those gaps. The first is called a uniform and second is called as non-uniform. In between these two, there is a gap, there is an electric field present, and all of you know it is given by the equation voltage upon distance. Now, I must tell you, this particular lecture I have divided into two parts. In initial part, I am going to talk about the types of gap, and in next part, I am going to cover the topic, that is corona discharge, its introduction, and the formation of corona. So let us start with this first type, that is type of gap as uniform field gap. You can see in this figure there are two electrodes separated by a distance d. One is referred as cathode, another is referred as anode. We can call this as uniform electric field because of the electric field which is present in between the gap of electrodes, which is same throughout its structure. So therefore, this kind of gap is called as electric field gap, that is uniform. In this case, under lower voltage, it is not possible to get the electric field, or rather it is quite impossible to get the corona discharge. But at the voltage increases, we can say that it is a breakdown voltage, the formation of corona takes place. And this corona formation is nothing but the post breakdown effect. And in previous lecture, we have already discussed that it is nothing but the arc and glow formation. So this arc is nothing but the corona formation, which follows the weaker path in case of uniform electric field gap. Another way is non-uniform field gap. The corona formation in this case is different than the previous gap. For that purpose, let us understand the first non-uniform field gap, where we have a pointed gap. If you just check the structure, at the center of it, the gap is less as compared to on the side of the electrodes. Therefore, the chances of occurrence of the corona discharge at this particular point, called as sharp points, is more. Even we can see that corona formation in second gap called as curved gap. So you can see in between these 2 points, the formation of corona or the chances of formation of that corona is more as compared to the gap which is present on the other side of the electrode. In case of uniform field gap, the corona follows the weaker path. In this particular system or a structure, the chances of formation of corona in lower gap is more. As we know, the electric field is equal to the breakdown voltage divided by distance. So if I just say breakdown voltage is directly proportional to the distance. Smaller the distance, for a same voltage, the chances of formation of corona is more. We can see that effect even on the third type of non-uniform field gap, that is the transmission line. This figure shows there is a tower on the left hand side of the figure, and there are transmission lines can be divided as red, yellow, blue. And the effect of corona is more pronounced even on all the three lines of the conductor. That corona travels from one pole to the other pole on all the three lines of the transmission line. During this travel, there are definitely certain points which takes place. So let us cover those points. The important points are the corona which is formed is bluish in color. The light, the luminescence which we get of related to corona, it is in bluish in color. At the same time, we can see or we can hear a noise called hissing noise, and due to the chemical reaction, there may be the formation of the gas. The air which surrounds the conductor of the transmission line is nothing but the corona region. And if that persists for a period, then that can be converted into the ozone. Another point is the loss of power. So this corona not only gives this kind of the gaseous formation noise, and we can see that visual is bluish color, but at the same time, due to its travel from one pole to the other pole, the loss of power takes place. And that power loss, it is in terms of the heat which is developed. So loss of power is nothing but the heat loss. Now, due to this heat and the chemical reaction which takes place due to which the gases are formed, that reduces the life of the insulation. The insulation means the insulators which are placed there, the insulation of the maybe the of material, etc., etc., and hence as the life reduces, the chances of the conversion of smaller breakdowns into the higher breakdowns, major breakdowns, is increases. At the same time, there is one more important point that must be noted, as there is effect called as radio interference. So it interferes the radio frequency also, because that corona not only carries the sound, but at the same time it affects on the radio. And another point is there are two corona effects. One is called as a visual corona, means the corona which can be easily visible to the eyes of the person, and another is a audible corona. The voltage at which the audible corona occurs is less as compared to visual corona. So visible corona needs higher voltage than the audible corona. Apart from these 5 points, there are few more points which can be noted here, as this particular corona depends on the voltage called as inception voltage. So this inception voltage for, that is corona field, for parallel wires of radius r can be written as, that can be given by the equation E. Now for this parallel wires, you can use it as E. P is equal to, the equation can be written as 30 into m into d multiplied by 1 plus 0.301 divided by in root of d into r. For coaxial cylinders, where the inner cylinder has a radius r, the equation can be written as 31 m into d into 1 plus 0.308 divided by root of d into r. where M stands for the surface irregularity factor. And in fact, that M becomes 1 if the surface is smooth and it is polished. Then D be the relative air density. It is just like a current density, flux density. So air density, the amount of air which is present. So relative current density, correction factor. As I already said, small r be the radius. This relative density is also written as 0.392 into P divided by 273 plus T, where P stands for pressure in torr. So the value for pressure says 760 torr as per standards, and T be the temperature. And if as per standards, if the temperature is 25 degrees Celsius, then the value of that D is equal to 1. The value of that D is equal to 1. Now, as we discussed, the related to the audible and visible voltages, and the voltages are given here. Apart from that, you can find the change in the color of the corona which appears based on the polarity of the voltage. If the voltage is positive, corona appears as uniform bluish white, and if the voltage is negative, the corona will appear like a reddish glowing spots. Even there are certain investigations that says for point plane gaps in air, when the point is negative, corona appears as current pulses called tertial pulses, and the repetition of frequency of these pulses increases as the applied voltage is increased and decreases with a decrease in pressure. Like positive point electrode, the point electrode has a negative value. If the point electrode has a negative value, then the corona which is formed, that is the corona is increases steadily with the increase in voltage. At sufficiently high voltage, that current amplification increases rapidly with the increase in voltage, and that may reaches to the value of 10 to the power minus 7 ampere. After which the current becomes pulsed with the repetition frequency of about 1 kilohertz and composed of small bursts. So this form of corona is called as burst corona. So this is nothing but the corona which we have for two different polarities of the voltages. Now let us understand the corona curve, that is characteristics depends on the spheres of different diameters in sphere plane gap geometry. So let us understand. Consider a sphere gap of arrangement separated by a certain distance. So if we plot the characteristics between the breakdown voltage for a gap distance D, this is nothing but the gap distance D, then we get, let us divide this characteristics into three parts, or rather three regions. The region says when the gap length is small, the voltage increases. So for small gap, the voltage increases and the field is uniform. So therefore that breakdown voltage mainly depends on the distance. But as the gap length increases, as the gap length increases, we get, now this is say second region. So at fairly large spacing, this is nothing but the large spacing. So this is say D1 distance, this is D2 spacing. For this particular region, the field is non-uniform and the breakdown voltage depends both on the sphere diameter and the spacing. So now for region 1, we have a uniform field gap, but as the spacing has increased, the gap becomes non-uniform. The gap becomes non-uniform. So region 1 is defining uniform field gap. Region 2 is defining non-uniform field gap. Further increase in the distance, makes that breakdown voltage constant, definitely makes that breakdown voltage constant. Okay, so here we can say this is what the start of the breakdown and this is what the corona inception. This is what the corona inception means, the corona starts. So the voltage at which that corona incepts or starts, that is called as inception voltage. So this is our region number 3. Here the spacing is large. Again, the field is non-uniform. The field gap is non-uniform. And the breakdown is preceded by a corona and controlled only by the spacing. So the corona inception voltage, which mainly depends on the sphere diameter. Okay, so this is all about the corona formation. Now, as I said, we are going to cover the corona effect also. So I have already pointed few important points related to corona, like the corona inception voltage, the color, the gas, the noise which is formed due to corona. Now, how this corona forms? We have, now let us consider a transmission line conductors separated by certain distance and hanging in between two towers. So ionization is always present surrounding the air which surrounds the electrodes or conductors of the transmission line. This ionization is due to many of the reasons, maybe cosmic rays, UV radiations, radioactivity, etc. So when we have this ionization surroundings the electrodes of the transmission line or conductors of the transmission line due to any of the reason, under normal condition, air around the conductors contains some ionized particles. Now, what is those ionized particles? Ionized particles, as we already defined, contains electrons and few positive ions with the neutral molecules. The neutral molecules of the air material. When potential difference is applied between the conductors, the potential gradient is set up. So the application of voltage gives or sets up the potential gradient. That sets up the potential gradient. Now that becomes maximum value at the conductor surface. So near the conductor surface that has the maximum value. So under the influence of potential gradient, the existing free electrons acquire the greater velocity. Greater velocity, it means that electrons freely moves from one point to the other point or other side of the transmission line which is hanging between the two towers. So when this electron travels, that cuts which is in the electric field that get collide and hence get bombarded with the neutral molecules of the air. Greater the applied voltage, greater the potential gradient, and more be the velocity of free electrons. So as this voltage is higher, the potential gradient is higher, and the electrons free mobility is higher. Now, as this potential gradient reaches to the value of say 30 kilovolt per centimeter, the velocity acquired by that electrons is sufficient to strike the neutral molecules. So when this electron strikes the neutral molecule with the enough force, that neutral molecule dislodge one more electron from it or few more electrons from it. This produces another ion with one or more number of electrons, and this electrons will move towards this other side with the positive ion on the other. Again, this movement of the electrons, now the electrons which are present due to the potential gradient and the electrons which are developed due to the collision with the neutral molecules have that movement, have that velocity to move. This produces another ion and few more number of electrons, and hence turns accelerated until they collide with other neutral molecules, thus producing other ions. So this gap, the avalanche get formed, and thus the process of ionization cumulatively results into the corona, and that is called as the spark which takes place between the conductors. So now as the gap of the conductors between the transmission line is completely filled with the electric field with ionizations, etc., the chances of formation of the corona that may surroundings the conductor and conductors, but also maybe the spark between the two electrodes. So there is need to maintain the sufficient gap between the two electrodes. That gap must be sufficiently maintained. And whenever we have that whenever we have that corona formation, that corona formation affects on the transmission line life, as well as that forms the power loss. So this is all about the corona discharge. I think all of you have understood what is mean by a corona discharge. Corona discharge is nothing but the kind of discharge which appears in the form of light, that is referred as corona. We have arc formation, corona formation, and even the lightning. All these three effects are the results of the ionization formation between the gap of the charge elements or charged particles. Like a lightning is formed between the charge clouds, corona is formed between the charge electric lines, the arc is formed between the charge electrodes in say circuit breakers. So hopefully you all have clear with this particular point. See, we cannot exactly define what is corona discharge, how that corona discharge will be, what are the exact reasons for that. So that study is still going on, and we are coming out with the different results related to this corona. But this corona discharge is really, really important, and that must be studied everywhere. So over here, I have given you the idea about the uniform field, non-uniform field gap, and the corona formation, that is corona discharge. How that corona forms, it is given in this particular slide. And last point which I have mentioned here is the difference between the arc, the corona, and the lightning. In fact, all these three are similar, but the only thing is it is formed in between two different charges. Like if arc is formed, it is in between two electrodes of the say circuit breaker. The corona is formed on the transmission line. The lightning is formed in between the two charge clouds. That is what the difference is. Otherwise, all are nothing but the formation of electric field. Nothing but the formation of electric field. So guys, that's all with this corona discharge. Thank you so much. Hope you will enjoy this lecture.